Professor K.S. Rao, Professor in the Department of Botany, University of Delhi. Actually, Professor is an eminent scientist, a leading academician in the country. First of all, on behalf of my own, on behalf of Madurai Kamaraj University, we thank and welcome Professor K.S. Rao for this winter school on climate change, past, present, and future. So today we are fortunate to have Professor as a resource person because of his vast experience in ecology. On various aspects of ecology, he published more than 150 research papers, contributed more than 10 books, guided 20 PhDs, completed many projects, including linking livelihood, climate change, vulnerability, and adaptability to climate change. With these few words, I welcome Professor K.S. Rao to deliver his special address to the participants. Sir, thank you, sir. Welcome, sir.
Okay, Dr. Chandrasekhar. Good morning. Welcome all participants. I will start my presentation, and then if you have any questions, you could either put it in the comments or you can ask it at the end. I hope you are able to see the slides.
Yes, sir.
Okay. See, I hope you are all senior faculty. You might have exposed to this discourse on the climate change, climate variability, and all those things. But still, as this topic of adaptability is related to the topic of the change that we are looking in the weather or the climate. So let us look at some of the fundamental definitions first and then move to the actual adaptation part. So you might have already seen what the definition of the climate is. So the climate is the weather conditions prevailing in an area in general or over a long period. So in literary terms, we use this climate in different ways. The best example is you say the working climate is not good, the current economic climate is bad, or something. That's the way we express in literary context. But it doesn't mean the actual climate in biological or environmental sciences view. Currently, if we look at the Intergovernmental Panel on Climate Change, has defined the climate as, in a narrow sense, is usually defined as the average weather, or more rigorously as the statistical description in terms of the mean and variability of relevant quantities over a period of time ranging from months to thousands or millions of years. The classical period for averaging these variables is 30 years, as defined by the World Meteorological Organization. So this is one thing a lot of people have been asking, why 30 years? What is the logic behind this coming to a conclusion that 30 years? So I have been trying to find out the answer for this specific question to address this to the students, but I never been able to get a scientifically viable answer why this 30 years has been coming. Because even if you look at all the statistical means that has been produced by the World Meteorological Organization, that doesn't give any inference to why 30 years has to be used. The only probable reason I come to know from the sociological angle is, if you look at any person working in an organization will have about 30 to 35 years of the service. So he will be collecting, interpreting all this data for about that period. So I assumed that probably the persons working in the World Meteorological Organization could have considered this during a working person's lifetime. The information that has been collected and interpreted is sufficient to draw some inferences in the climate change, and thus could have defined this as the 30-year period as the minimum requirement. This is what the logical conclusion I was able to come. Otherwise, I haven't found any scientific definition which indicates that this 30 years is sufficient or not sufficient or like that. So I assume that this, if you have any further information on why this 30 years average is considered as the good for considering the climate variability, you could look into it. The relevant quantities are most often surface variables such as temperature, precipitation, and wind. Climate in wider sense is the state, including statistical description of the climate system. But if you look at most of the climate discourses, you will find that we are putting too much emphasis on the temperature and the precipitation. The wind is not in any of the models or equations. It is only the meteorologist who is looking in terms of the wind as the direction which it is influencing all the parameters. I hope the slides are moving. Can anybody confirm?
Sir.
Are this moving?
Sir, moving, sir.
Yeah, okay. So variability in climate is what we are actually looking for, which the adaptation is taking place by the biological organisms. So the climate variability could be defined as variations in the mean state and other statistics of the climate on all temporal and spatial scales beyond individual weather events. And then you will be asking what is individual weather events. So you might be knowing by the morning when we woke up, you will be seeing it is a sunny day, it could be rainy day, it could be a chilly day, depending on what we feel. So that is individual weather events at any given point of time. But when we look in terms of the climate variability, you could look in terms of the seasonal variability, diurnal variability. So that's one reason daily in the weather bulletins, you will get daily maximum, daily minimum temperature, the total rainfall during a specific period, and relative humidity at any given point of time. All these variables are going to be critical in terms of adaptation.
Excuse me, sir. The
yeah.
slides are not moving, sir.
It is still in the climate change?
Still in the title of the presentation.
Okay, let me. I think when I do the presentation mode, they are having problems. So let us not.
You have to share the slideshow screen, sir. A slideshow window.
Yeah, I have.
Now it is moving, sir. Now it is moving.
Okay. So we are first slide is the climate. We have defined it, and then the variability in the climate. Now we are looking at. So the term climate variability is often used to denote deviations of climatic statistics over a given period of time, that is a month, season, or a year, when compared to long-term statistics for the same calendar period. Climate variability is measured by these deviations, which are usually termed anomalies. So in the climate science, this anomaly is going to be the most critical one. And anomaly from what? From a benchmark mean. And this benchmark mean is always defined by the researcher saying, okay, I am taking the mean of 1950 to 1980, and then looking at post 1980, what is the deviation that I have in terms of the maximum temperature, minimum temperature, or the monsoons. So that's why in the every report that you will see IPCC has produced, the mean of a specific period is mentioned, and then from there how it has deviated. So as we move into the lecture, in the graphs you will see how the deviations has been looked upon in terms of how these parameters are changing. So variability may be due to natural internal processes within the climate system, and or the variations in natural or anthropogenic extreme factors. So you will be seeing both the natural forcing and anthropogenic forcing influenced events, which is important in the climate science. And the third term is the climate change, for which we are looking in terms of the adaptation. So the climate change refers to statistically significant variation in either the mean state of the climate or its variability, persisting for an extended period, typically decades or longer. So here, if you look at, one is a individual mean variation. So you will be saying, as compared to mean of 1950 to 1960, the temperatures of 1980 to 1990 is higher, lower, or this way, or you are looking at. The other is you are saying that the temperatures of June 30 is highest as compared to the last 10 years, last 100 years. This is what we are saying in the newspaper, saying that the June 30th temperature in Chennai is maximum for the last 100 years this year. And if you ask anybody who has been living for 80 years, 90 years, he will say that this year it seems to be more hotter as compared to all the years I was living. The reason is your ability to perceive these temperatures will be changing depending on how you were exposed earlier and how much of that exposure you still able to remember or record in your memory. And thus, even though the temperatures sometimes are lower than earlier, you could be still feeling that it is greater than earlier. And thus the perceptions could be different as compared to the actual measurements. And this is what actually gives us difficulty in terms of interpreting the adaptation data, because when you go to the people and ask what you experienced earlier and what you are experiencing now and what changes you have made in terms of to meet such differences, the people is not able to comprehend what these parameters has changed and why he has to adapt. So his way of expression is entirely different, and from where we have to infer how these changes has actually influenced this adaptation. Otherwise, it is going to be extremely difficult. And thus, the literature in adaptation is having high degree of variation and individual biases in terms of expressing the adaptation to the climate variability or climate change. The climate change may be due to the natural internal process or external factors such as the persistent changes to the atmosphere or changes in land use. This is something I think everybody might have perceived. If you are staying near to the coastal region, the temperatures are normally will not be varying too much. If you are staying near to the dense vegetated area, as compared to the less vegetated area, the temperatures could be slightly lower. And all these factors are microclimatic variations created by the habitat variations. And thus, the land use is also going to be an important factor in terms of the how the climate is or the weather of specific region is responding. In terms of the Article 1 of the United Nations Framework Convention on Climate Change, that the UNFCCC defines climate change as a change of climate which is attributed directly or indirectly to human activity that alters the composition of the global atmosphere and which is in addition to natural climate variability observed over comparable time periods. So you have to be very careful with this definition. UNFCCC looks at the natural forcing and anthropogenic forcing as a separate parameters and gives more emphasis here on the anthropogenic forcing as the important driver for the climate variability. The UNFCCC thus makes a distinction between climate change attributable to the human activities altering the atmospheric composition and climate variability attributable to the natural causes. So what is the difference between the climate variability and climate change? So in literature, we might have found that the use of these terms interchanging and people might get confused with the variability with the change. In essence, the climate variability looks at changes that occur within smaller time frames, such as a month, a season, or a year, and climate change considers changes that occur over a longer period of time, typically over decades or longer. So, in principle, as we have seen, the climate change is more than 30 years or minimum 30 years, but variability is for a shorter period. So when we are looking in terms of the data averages, comparing between the two periods, it is when it is less than 30 years, probably we are discussing more of the climate variability, but change could be attributed only when we have very long durations. A key difference between climate variability and change is in persistence of anomalous conditions when events that used to be rare occur more frequently and vice versa. Obviously, now climate scientists are saying that for a layman, if the extreme events or the anomalous events are occurring more frequently, then it is indicating for him it as the climate change. So the continuous dry periods, the continuous wet periods, continuous flooding, continuous sea level rises, all these things are now considered for the layman as the inferences for the climate change, and thus a persistence of the anomalous conditions is now considered as the, in general, the climate change. In statistical terms, the curve of the frequency distribution representing the probability of specific meteorological events changes. The curve may be modified either in amplitude, shifted about a new mean, or both. This, if you have seen in terms of explaining the amplitude and the means and the skewing of the parameters, you might have already seen in the climate discourse what these terms mean. Care must be taken not to confuse variability with change. Many regions of the world experience greater variability, climatologically speaking, than do others. This, in some parts of the world or in any region, for certain time periods or parts of the year, the variability can be weak. That is, there is not much difference in the conditions within that time period. In other places or time periods, the conditions can swing across a large range from freezing to very warm or from very wet to very dry and exhibit strong variability. And this is one reason you might have seen that the Indo-Gangetic plains, you will find extreme summers, extreme winters, but this may not be true when you go into the southern parts of the country and near to the sea coasts. You will not find such strong variability in terms of the seasons. And diurnal variations are very high when you go into the cold arid regions in the Himalayan system. So you will find extremely cold nights and extremely warm days during the day. Adaptation is our focus of this lecture. So what is adaptation? It has several meanings literally. We will not discuss those things, but in terms of our climate change science, the Intergovernmental Panel on Climate Change defines adaptation as the process of adjustment to actual or expected climate and its effects. In human systems, adaptation seeks to moderate or avoid harm or exploit beneficial opportunities. In some natural systems, human intervention may facilitate adjustment to expected climate and its effects. This adjustment includes many areas such as infrastructure, agriculture, and education. So the adaptation is important. In ecology, when we talk in terms of adaptation to the abiotic factors, we will be talking in terms of the two things. One is resistance, the other is tolerance. That is, individual organisms is trying to adjust to the changes, the abiotic factors are the forces that the abiotic factors are going to. So the abiotic factors are common in the climate science also. Then we are not talking about the resistance and tolerance there. So the adaptation here could be in terms of acclimatization first, and then trying to change a physiological or habitat mechanisms through which the society is adapting. So here in the sociological perspective, the adaptation we are looking in terms of how the human society is responding to the impacts of change in temperature, change in precipitation, or could be a combined effect of temperature and precipitation. So the temperature and moisture, which is responsible in terms of providing the productivity that is required as the food or the industrial resources for the human society, need to be maintained at the required production levels, and thus these two important variables of weather is considered to be important for adaptation. So the human society's adaptation is basically to look at when these parameters change, how to make adjustments so as the required resource production is continued. So we are looking in terms of ecologically, the provisioning services has to be maintained at an optimum level so as the human society's sustenance and economic activities are continued. And this is one reason, if you look in terms of the climate discourses, the Millennium Development Goals earlier and currently the SDGs, Sustainable Development Goals, is discussing the adaptation as the important. So the other parameters is the mitigation. Mitigation is looked in terms of in different way, but adaptation is a thing that where we are accepting that the change is inevitable, and to survive we have to adapt to that change. This is where the adaptation is becoming very important, and while the mitigation is very costly, the adaptation is considered to be the easier way for the human society to survive. Let us see how this in terms of economics, whether the adaptation is cheaper or the mitigation is cheaper, or a combined effort of the mitigation and adaptation has to be used, which is the important policy discourse the people are looking at. The climate change adaptation is a response to global warming, which is known as the climate change. So what is the climate change that you might have seen in some of the other lectures you have attended? The climate change includes both the global warming driven by human emissions of greenhouse gases and the resulting large-scale shifts in the weather patterns. It could be due to natural forcing or due to anthropogenic forcing. So let us look at this left panel. So the temperature change in the last 50 years. So what it is actually showing. The average global temperatures from 2010 to 2019 compared to the baseline average from 1951 to 1978. So the average value of 51 to 78 is first taken, and from there between 2010 and 19. So the average value of the 2010 to 19 is compared with the 1951 to 1978 and has seen in terms of how much deviation has taken place. And as you could see from the zero, it is moving towards the plus and minus. So you will be seeing here the temperatures are less as compared to the average of 1951 to 78, and here it is greater than the averages of the 1951 to 1978. From the map now you could infer the northern polar region is the where the temperatures has increased by 4 degrees, whereas if you consider India as the important the place where we are living, then it is between 0.5 to 1 degree centigrade increase. So this is where the climate science is trying to look at in terms of a baseline average, how much deviation is taking place that is considered as the change. So when you change this baseline, the variation also is going to change. And thus it is important to have a understanding what is the baseline from which we are talking about the change. If you could take last 5 years average and see what is the deviation it has this year, you might have found that not much variation has occurred, because in recently last 10 years is almost very warm. And if you consider the 5 years and this year, then the variation could be very, very less, or probably this year could be less warmer as compared to the average value of the last 5 years. And thus it is important to have a understanding about the baseline from which we are talking about. Then the second panel you could look at, this is talking about in terms of anthropogenic forcing and natural forcing. So you could see the green line, which is talking about change from the pre-industrial, that is 1952, it is talking. And then it is looking in terms of is the temperatures are different from that period or not. So using the only natural forcing from the models, they have found it is not changing much. So it is when you use the human activities only, you will see it is increasing, and it is matching with the observed temperatures. So people consider that all the global warming that is taking place is predominantly because of the anthropogenic activities, and thus the actual influence of natural forcing is not so great as compared to the anthropogenic forcing. So as a layman, we could see that the climate is changing in terms of the temperatures are rising, sea levels are rising, the ocean is acidifying. Climate change is reflected in water cycle changes and in extreme weathers, and thus it is influencing every living organism on this earth, and thus influencing the sustenance of the human society. And humans are the ones who are looking in terms of how to adjust to these changes. And if you look at the warming of the climate system, you will be seeing that the last decade is the one which is considered to be the warmest years. So this is the warmest 12 years on record as the temperature, so increasing the global average age and ocean temperatures. Then the rising of global average sea level. So you could see from this panel, the sea level is also increasing, and this is from the mean of the 1961 to 1990. And reductions in the snow ice. So people has been monitoring the snowbound areas in the polar region and other places, and has been seeing the total amount of the area under the snow, because the global warming potential is increasing if you have less albedo effect. And the more the snow area, the more the albedo effect, and thus it is important to have more snow areas. And this shows it is decreasing. And thus it is becoming important to understand that these parameters are the ones which are clear scientific evidence that the global warming or this climate change is happening. The other one is you could look at the these two pictures. This is 1992 and this is 2002. This is what shows the total amount of ice covered area in the Greenland, which has reduced, and in relation to the temperatures. You could see that the temperature shows that it is increased by about 1 degree centigrade from 1900 to 2000. So in 100 years, about 1 degree centigrade increase, and this is the amount of the ice cover loss that we have encountered on a very important. Why this Greenland ice is important? The thermohaline circulation, which is important in terms of maintaining the weather systems at present in the continental plates that were situated, is driven by the total amount of the ice that is present in the Greenland. And people are worried if there is no ice, this thermohaline circulation is going to be disrupted. And once that is disrupted, the global biogeochemical cycle is also going to get affected because the circulation of the minerals from one ocean to the other oceans will be changing. And also, the global water cycle is going to get affected because the differential in the warming potential in different seas because of the salinity change is going to influence regions differently. And thus, people are more worried about this important driver of the thermohaline circulation. Now, let's just pass through this slide. This is basically, as you are aware, that the amount of the greenhouse gases that are responsible for this. So we are talking about greenhouse gas global warming. Without greenhouse gases, life could have never occurred on this earth. The temperatures are supposed to be -20 if without this greenhouse gas effect. And because of their presence only, the temperatures are now in a +20 state, and thus the life is able to originate and diversify on this earth. But why we are worried about greenhouse gases is the rate at which they are now increasing is leading to a geological status where the greenhouse gases concentration in atmosphere is going to be such great that the life forms of present geological era may not be able to adapt to that levels of the greenhouse gases. And humans never occurred when the greenhouse gases were in that high status. And thus the survival of the humankind on this earth is what is the big question for the anthropogenic society, so as the greenhouse gas controlling systems is discussed. To just refresh, the carbon dioxide, which is highest in the amount, is increasing. So from 290 ppm, it is increased to 380 by 2007 years. In some reports shows that by 2010 plus or 2018, it has almost crossed 400 ppm. And the projected concentration in the year 2030 is 400, but we have seems to be already reached that. So by 2030, it could be crossing 400 ppm plus. The atmospheric lifetime is varying between 5 to 200. When it is in the oceanic sediments, it is about 200 years, but when it is in the other forms, it could be about 5 years. And the global warming potential is referenced as carbon dioxide with the 1. And this is the reference, and all other greenhouse gases is considered from this point to how much is the increasing. So you could see that every part of the greenhouse gas is increasing. So we have been able to have the several regulations which is regulating the chlorofluorocarbons, and thus the rate at which they are increasing is not greater. But When you look in terms of the global warming potential, the methane is 25 times greater, nitrous oxide is 200, about 300 times greater, and chlorofluorocarbons are very vastly influencing. So the small amount of chlorofluorocarbons could be deleteriously influence the global climate for the human society. In terms of the IPCC's outlook, the NX1 countries, which has about less than 20% of the global population, is using a lot of carbon dioxide per capita. You could see that the Americas and Canada is plus 26, whereas the developing countries, non-NX1 countries, where the population is high, more than 80% population, is actually contributing very, very less per capita. But when we multiply per capita with the total population, it is almost identical to the NX1 countries. And this is where we have differences of opinion when we have negotiations. Who is responsible and who should contribute in terms of reduction? The developed countries argue that the total volume of our contribution is equivalent to all those people who are living in the developing countries. So both are equally responsible. But the developing countries are arguing we haven't yet developed. You have consumed all the resources, and your ecological footprint is more than 10 times than us. So you should be taking more precaution. You should reduce your ecological footprint so as we could actually reduce the global warming potential. And this discourse is what is hampering the discussions to adjust the global warming potential contributions by each of the nations. In vulnerability in developing countries is mainly considered to be because of the low human capital. And this in terms of the number of human beings are very high in developing countries, but the capable humans to address the climate change mitigation or adaptation is less. Low in financial capital, low potential for employment, low income, low capability to face changes in climate and ensure sustainability. So it is considered even a developed country like the US or the Europe are also not capable in terms of facing the extreme events. The unprecedented flooding in US, the extreme temperatures in the Europe has shown that even though they consider they are having high capability, they are not able to face this challenge of climate change because their predictions that the human society is able to adapt to such changes and they are prepared for that is found to be untrue. The enhancement of adaptive capacity is thus essential, and thus we will be looking in terms of this adaptive capacity, what it is actually means. The examples of impacts associated with the average annual global change of temperature is summarized here. The greater the temperature, the more components of our society will be reached and more intensively. So, in terms of assessment report 4 by the IPCC, you will find the greatest impact is going to be the water, then the biodiversity in the ecosystems, which influence the food self-sufficiency, and in the coastal regions, the inundation and the extreme event damages, and in general, the human health because of the vector-borne diseases are going to influence the human society's health. So you could see that we have already has been influenced up to the 2 degrees centigrade increases, and in some places the 3 degrees centigrade increases. So it is expected that people are predicting by 2020 or 2030 we will be reaching to 5 degree or 6 degree temperature increase over the baseline average. And this is where we are actually trying to look at how the adaptation should be looked at. So the IPCC assessment reports are actually looking in terms of what are the activities each of these countries are taking to respond to this deviation from the average, and how in each of these major sector the adaptation efforts has been done by each of these countries. So this is from the Millennium Development Goals, the old ones in terms of the changes in mean climate variability, extreme events, and sea level rise. You will see the increase in temperature and changes precipitation reduces the agricultural and natural resources, which will be increasing the vulnerability of the weaker sections in the society because their dependence on common resources is greater, and thus they will have the less secure livelihood, and this is going to increase the health risks, and then will be having influence on the total economic productivity of that society. And this vicious circle of resource constraint, health risks, and economic development decrease is going to affect the goals that has been set in the Millennium Development Goals, and thus the discourse in the developing literature shows that the adaptation by each of these countries is going to be critical, and thus the Human Development Index, people are looking in terms of the what are those parameters that has to be considered in terms of the natural resource management and adaptation as the important drivers to look at the adaptation of the communities to the climate change. The increasing frequency of the damages from the disasters in the Asia-Pacific region is shown here. The total damages and the hydrological one is here, the climatological, meteorological, and geophysical. So you'll find that the earthquakes, the meteorological, that is the rainfall, and the climatological. So you'll find that extreme events are increasing post 2000. So the frequency at which you are having extreme events has been increasing, which is also responsible in terms of the number of disasters that has been reported across the Asia-Pacific region. From the national communications, the IPCC has looked at what are the priority sectors in which people are looking in terms of making adaptation. Obviously, agriculture has become the 100%. Every country has reported their focus is on the adaptation to the agriculture. This means that the societies are looking in terms of food self-sufficiency, food production, because people consider that any amount of climate change variation requires a quick adaptation in the agriculture production sector, thus to ensure the food self-sufficiency. Then becomes the all other sectors. You will find that the water resource is the next highest priority, because the drinking water availability or the industrial water requirements meeting is going to be considered as the other important one. Then you will find that the health has been considered as the other important one, and the early warning systems of the disaster management is considered to be the other one. And in the countries where coastal resource dependence is higher, especially in this Asia Pacific, it is considered as the important area, because the frequent cyclones has disturbed the livelihoods of the several communities that are dependent on both marine and the coastal resources, and thus these are the priority sectors that have been reported in the national communications, where these countries are looking in terms of adaptability is important for the societies to survive in the given climate change regimes that are predicted. The steps in planned adaptation to climate change that was discussed by the Stacker in the 2006 shows the climate change or the climate variability is going to generate impacts, and this requires the first awareness that as the climate change is there and it is generating these impacts. Once you are aware, only then you will start looking at the planning, implementation, and this is a continuous process of evaluation and monitoring. So the administrative structure has continuously look in terms of evaluate the actions in terms of whether they are sufficient or not, and thus continuously changing. So the planning requires the policy support and the development infrastructure. The impacts are going to be based on the management practices, whether the management practices need to be altered or it is getting reduced or enhanced by the other stressful activities. So you might have seen that climate change impact could be greater in the highly polluted areas as compared to the less polluted areas. And thus it is going to be important to look into the other stresses. So this evaluation and monitoring will be leading to the change in the management practices, and also in terms of national outlook, the mitigation is going to be the other important aspect. If you are addressing sufficiently on the mitigation also, then adaptation is also going to be easily adjustable, and thus mitigation as the alternate pathway is also considered to be important. In terms of sustainable development goals and climate change adaptation, you will see the adaptation to the climate change depends on the economic decisions, the dimension, and the social dimension, and ecological dimension. In the ecological dimension, we are looking in terms of how the biodiversity is going to get affected. In the economic dimension, we are looking in terms of how much investment the societies are willing to put in terms of developing the infrastructure to adapt to the possible changes that are reported based on the models. And the social dimension is how amiable the society is for such changes. The problem with the human society is we are very resistant to any proposed change. We will first ask, why do I need to do this change? Why can't I live in the same way? And this is where it is important to look in terms of the social dimensions also, and make the society to understand this required changes is going to be important. Unless you do that changes, there is going to be difficulty. Today, we are looking in terms of a high degree of inequality in the society. There are people with the high amount of resource access and availability. There are people with very low resource access and having greater vulnerability to any minor changes. So if they had some resources, they could have still withstood any change and adapt to that one. And thus it is going to be important in terms of the sustainable development goals to consider all the three important pillars to look in terms of adaptation to the climate change. In terms of the adaptation measures, we consider that policy measures are going to be very important. If the administrators doesn't take appropriate policy measures, even though the technological knowledge is available, it is not going to be useful. While the policy makers take appropriate policy measures, you should also have appropriate technological knowledge. And those technological measures is also going to be important. So as the technology develops, the policy also should willing to adopt such technological advancements so as adaptation becomes easier. And thus, these policy measures and technological measures are going to be very, very critical in terms of the discourse of the adaptation. And if we are not going to invest in the technological measures and depend only on the policy measures, we have some difficulty because we have been seeing initially importing several of the technologies from other regions and has found that those technologies are not suitable to our environments. And thus, it required a lot of investment in terms of modifying such technologies. And thus, it is important to have proper technological development and support from the policy. And these two are going to be critical in terms of the society's adaptation. And then, from the society's perspective, the climate responsive change in location, activity, and use. If the society is willing to change their activity profile, their natural resource use profile, and probably in sometimes they may have to leave the area. Land use conversions is going to be critical. And then the monitoring and forecasting. We are very strong now in terms of the forecasting, but the accuracy of this forecasting is increasing with the modeling efficiency increases, but it requires continuous support by the monitoring. And the infrastructure that is required for monitoring is also important, and investment in the mechanisms of monitoring is going to be greater. And when we lack this proper monitoring, this is where we will be failing in terms of forecasting, and thus the policy measures and technological measures becomes weaker because we will not be geared up to increase these two to required outcomes that is predicted by the forecasting. And then the risk sharing. This is now becoming important in the climate change discourses and adaptation discourses. We have resource inequality, and thus the risk sharing is becoming. And in terms of the government perspective, people are looking in terms of the insurance. So we have been looking in terms of insurance, especially in agriculture, the crop insurance schemes that has been introduced by the government, and all those things are coming under the risk sharing mechanism. So we will look in some of these how that are existing in India. The other one is the vulnerability of each of the region. In the scientific discourse, the technology, people are looking in terms of the vulnerability to the climate change, how it is happening. So there are three important determinants: the exposure, the sensitivity, and adaptive capacity. And we are looking in terms of the adaptive capacity of the society. So the adaptive capacity at present in the discourse is looked in terms of the cropping intensity, the percentage of the irrigated area, average fertilizer use, percentage of the village with the electricity, and several other parameters. And in terms of the sensitivity, people are looking in terms of what is the soil organic carbon content or its change, available soil water capacity, population density, average yield, and all those things. And in terms of the exposure, they are looking in terms of the abiotic factors, the temperature maximum, temperature minimum, and how it is deviating from the benchmark. So the period of the drought, and all these things are creating the potential impact and the vulnerability, and thus the vulnerability index is indicating the society's ability of adaptive capacity to the exposure and sensitivity of the ecosystems. From the technological perspective, there are several things. But being an ecologist, I consider the ecosystem-based adaptation framework as the most important one. Ecosystems are providing goods and services, and thus the sustainable, resilient ecosystems are going to be the most critical for the adaptation. The resilient society in the face of climate change and other threats could be possible only if you have the sustainable, resilient ecosystem. And when we're talking about resilient ecosystems, the ecosystem resilience is, we elaborate it as the ability of ecosystem to come back to earlier functional system that is existing before the disturbance. So the disturbances could be natural or anthropogenic. Here we are looking in terms of natural and anthropogenic together. So the sustainable adaptive management is what is required from the society to maintain the ecosystems in a resilient way, so as the goods and services that are required from the ecosystems is harvested by the society. And here the ecological footprint and carrying capacity are considered to be most critical parameters. And all the literature discourses says that most of the countries has crossed the biocapacity of their productive systems. This means that the humans has been harvesting resources from the ecosystems beyond the acceptable limits, and thus weakening the resilience of the ecosystems. And this is one reason we have been increasingly getting less of the ecosystem goods and services from the natural ecosystems, and we have been increasingly relying on the built up capital. So we have to use more air conditioner, more water purifying systems, etc., to get the naturally available favorable climate to the human societies and potable drinking water and industrial waters from the natural sources. And thus it is important for looking at how do we address this issue of resilience of the ecosystems restored back, so as the human societies are able to adapt to that. So this is going to be the most important technological change that is required as I look at. In terms of the ecosystems, the forests and trees are the most critical one, which is providing the provisioning services, the products, and in terms of the regulating services to the agriculture, the watersheds, the coastal regions, the cities, and the regional climate. So you will be looking in terms of the local adaptation, meso level adaptation, and regional adaptation at each of these 5 cases. The 6 cases linking the forest and tree ecosystem services to adaptation can be distinguished from the analysis. The forest and trees providing goods to local communities coping with the climate variability. Trees regulating water, soil, and microclimate in agriculture fields for increased resilience. Forest regulating water and protecting soils in watersheds for increased resilience. Forests protecting coastal areas from climate-related threats. Urban forests and trees regulating temperature and water for the resilient cities, and forests regulating atmospheric pressure and moisture, thus influencing rainfall at the regional scale. So it is considered that when the regional climate could be influenced by the amount of the vegetated to non-vegetated zones, because the evapotranspiration from the sea surfaces and the land surfaces is what is creating the high pressure at the low pressure areas because of the temperature regulations, and which are actually regulating the regional weather parameters. And thus it is considered to be important adaptation that the human societies should look in terms of having more forests and trees to have a sustainable, resilient societies in the face of climate change. So the conserving ecosystems for their adaptation services can contribute to conserving its mitigation service. So one is adaptation, the other is the mitigation also. In terms of the co-benefits or correlations between the services can be materialized at different levels. A forested watershed that is conserved for water regulation at the meso level can contribute to adaptation at the local level by providing forest goods for livelihoods and services for agriculture. The same example can be given with mangroves that protect coastal settlements, reefs, and fisheries at the meso level and offer goods for communities at the local level. But forested watersheds and mangroves also contribute to mitigate the climate change by sequestering the and strong and storing carbon. This is a global effect and benefit. And thus, our effort to regulate the ecosystem dependent society development could lead to one is adaptation to the climate change, the other is mitigating the climate change. So thus this global regulation surveys will also add to the global carbon climate change mitigation effort also. Thus you will be getting adaptation as the important service that could also lead to mitigation service also. Then becomes the costs of the climate change. People has been saying that if 1 degree change occurs, what is going to be the total cost on to the society? And if 2 degrees, which is now accepted by the IPCC as possibly from the 1952, that is pre-industrial averages, the cost of mitigation and it is reducing the extent of climate change, limit the overall temperature increase to 2 degrees. The cost of adaptation is reducing the impact of climate change, invest in coastal protection to limit the negative impacts of 2 degree centigrade warming and the residual impact cost that can neither be mitigated nor adapted to accept the loss of the certain coastlines because they cannot be defended at a reasonable cost. So these are the things that people are looking in terms of looking at what is going to be the costs for the human society. And adaptation cost and the equity is also looked. So United Nations Development Program calculates that by 2020, adaptation will cost nearly $86 billion per year. And World Bank estimation puts that number closer to $100 billion. Thus, you have almost about identical 100 billion requirement per year for adaptation alone. So when we look in terms of the equity aspects, the sufferers are usually not the contributors to the adverse effects of the climate change. This is the argument the developed countries and developing countries are still not agreeing upon. People in the developing countries still argue that we are not the ones who are contributing more, but the developed countries still argue that because of your numbers, you are also equally contributing to this change. Adaptation costs would be additional costs to development initiative to maintain the pre-climate change welfare levels. It involves allocation of resources to adapt to climate change while also meeting the needs of other sectors. Accurate costs of adaptation is difficult to estimate but essential. Accurate information and data at the disaggregated level is essential for proper policy framing and allocation of resources. This is where we have big difficulty. And in the recent administrative decisions, we have seen that the micro level planning at panchayat level has become important. Unless we actually have accurate information at the disaggregated panchayat level, it is becoming difficult to actually see what is required at what place. And thus, the adaptation costs and the meeting the equity requirements require accurate information to plan properly. In terms of the funding resources for adaptation measures, adaptation measures can prove to be very costly in most of the developing countries, but also developed nations also feel it is very costly because the level at which their consumption is there, to reduce it itself is a double-sided edge for them. One is they have to make the society to accept, and the resistance they will get from the society also is going to be important. How to compensate that? It also involves equity aspects, as those suffering the ill effects of climate change may not be the creators of the problem. Developing countries expect the developed countries to fund the adaptation measures. So most of the negotiations are still looking in terms of what should be the NX1 countries should do in terms of non-NX1 countries' activities. How much fund should be allocated from the NX1 countries to the activities in the non-NX countries, so as they will be able to do the proper implementation of the measures that are required for the potential. You might have seen in India, people are discussing in terms of the traditional societies doing shifting agriculture are the biggest reason for the climate change. People are talking globally. The wet rice cultivation is the biggest contributor to the methane generation in the Southeast Asia. So people are arguing that the people who are doing agriculture are the biggest culprit. But when we look in terms of the total volume of change that has been contributed in India, development projects are the ones which are contributing maximum. You are encroaching upon to the forest, continuing to do the land use change by constructing the hydroelectric projects, by constructing the national highways, etc., and industrial development corridors. So the contribution in the development activities are greater as compared to the contribution to the global climate change by the simple farmers who are trying to produce the food that is required for the societies. And thus the thinking that the poor farmers are the contributor to the most of the problems that has been seen is actually wrong. The adaptation policy measures in India could be seen in terms of the what has been done by the governments now. So if you look at the reports that the national government is submitting to the IPCC, in June 2008, India announced its National Action Plan on the Climate Change. So as the world knows what India is trying to adjust to, the plan covers 8 broad areas through its national missions, which takes care of both mitigation and adaptation measures. And these 8 missions are the solar mission, the mission for the enhanced energy efficiency, the national mission for sustainable habitat, national water mission, national mission for sustaining Himalayan ecosystem, national mission for the green India, national mission for sustainable agriculture, national mission on strategic knowledge for climate change. So these are the 8 missions that has been given under the climate change adaptation mechanism. So each of these missions have a technology development and research and development component. The adaptation components in India are crop improvement and the development research, the drought proofing and flood control, health improvement and prevention of disease, risk financing, disaster management, forest conservation, poverty elevation, and livelihood preservation. So if you look at all these components of the adaptation, you'll find that the investments that the government is making in terms of all these activities, you'll find there is a lot of risk financing in terms of insurancing. You have a lot of investment that has been put into the disaster management and also the services that are required for the crop improvement and drought proofing. So there is employment generation activities under the MNREGA and other activities. So we will see some of the adaptation mechanisms under the policy perspective. So the policy initiatives for the adaptation could be looked in from the rural employment generating schemes like the National Rural Employment Guarantee Act for livelihood security in the rural areas, where watershed development projects, urban employment programs for the tribal youth, afforestation, infrastructure investment, and the insurance are also important ones. So the method of implementation is under the concept of public-private partnership. The government is looking at strengthening the investments. Involving all the stakeholders is what is the priority. The central ministries and agencies, the state governments, business and industry, civil society, community level organization and representatives are trying to coordinate with each other so as the implementation is done properly. Both mitigation and adaptation measures are addressed in all the missions. So all these missions are looking from the central government to panchayat level. How do we address the issue of adaptation and also help the mitigation measures? In terms of the policy action for successful adaptation, accurate and disaggregated data is absolutely essential. So thus the data collection is the important activity that is happening. So that's one reason why, though India has the complete census every decade, we are also now looking in terms of looking at climate smart cities, climate smart agriculture, and other important data sets that has been looked upon. Improve the lack of balance approach towards the addressing all villages and taluks. It would be worthwhile to involve academic institutions to conduct surveys for assessing the adaptation needs of the various sectors. So this is where the discussion is happening, whether it should be outsourced to the academic institutions or should be left to the sectorial administrative systems that are existing at present. The public academic community policy action would give a fair idea about how much to adopt and which sectors should be given priority and in which areas and regions. Training workshops to train the trainers is essential so that survey instruments are formulated accurately to get the desired data. Incorporating adaptation fund allocation to the annual budgets at the local level. Municipality and village panchayat officials should be sensitized to incorporate adaptation measures with adequate consultation and cooperation to the local residents. This is what the policy perspective in terms of the missions are looking at. So let us look at what India is doing. The financial allocations to the climate resilient programs in India could be seen for the 1915-16 year itself. It shows that a lot has been invested in terms of the employment generation activities. Followed by you have agriculture and water conservation. You could see 5,300 crores in Pradhan Mantri Krishi Sinchai Yojana, and then Krishi Unnati Yojana 3,257 crores, and then Rashtriya Krishi Vikas Yojana where 4,500 crores. Together you could see about 15,000 crores has been invested in terms of food production, agriculture, sustainability, and also water management. In terms of the ensuring the uncertain events, you have about 2,600 crores has been added. And then animal husbandry also had about 451, and the blue revolution fisheries, etc. It has 410 crores. And then you have national rural livelihood missions, about 3,343 crores. So all this is predominantly looking in terms of the agriculture, employment generation, And in terms of ecosystem management, you have national afforestation about 688 crores and urban rejuvenation about 6,000 crores. This is where the smart city initiative has been invested upon. In rural missions, about 300 more crores has been invested during the 2015 and 16 budget reallocation itself. The adaptation strategies that were listed from the consultative meetings with the farmers at various places in agroclimatic zones has been listed. About 28 priorities has been listed by the people in various agroclimatic zones. Of this, some of them are important for the specific regions, but commonly you could say climate-ready crop varieties. This is what everywhere people are talking about. Water-saving technologies has to be introduced. Changing planting date, specifically in the monsoon-dependent agriculture areas, the crop insurance, which has been now implemented across, the precision farming, improved nutrient management, rainwater harvesting, improved weather-based agro-advisory, which has been addressed by the India at a greater scale. Now people get even a fortnight advisory in general and specific advisory for 3 days. Intercropping and mixed cropping, indigenous technical knowledge utilization. So there are several of the strategies that has been recommended by the various farmers and groups that are addressing the adaptation to the climate change. The adaptation options in the agriculture could be looked in terms of using different crops, could lead to producing new varieties, physical land improvement to control soil erosion, improved water holding and capacity for the soil that will lead to the activities that will increase the water retention and also decrease the soil losses so as the crop productivity could be improved upon. Improve water use and sources. So using the plastics in agriculture has considered as the important development. Making a change in cultural practices in order to maintain the nutrient and soil. This is where the organic, inorganic balancing, crop rotations, crop holidays in some of the areas where pest incidence is greater, all these things are becoming and important parameters. So micro irrigation in the dry areas has been supported by the government in a greater way. Adjusting timing of different farming activities is considered to be important because both the labor costs, so you could see the Indo-Gangetic Plains and Punjab, the labor has to migrate from the east to west to meet the planting dates and harvesting dates. And thus the adjusting the timing with relation to the climate and the labor availability is becoming important in several regions. And thus it is an important thing. So sustain the food requirements of the society, the adaptation in both the climate and the human capabilities are going to be important. Okay, this is the technical aspect in terms of the growth of the crops. You will be seeing that how the temperature increasing is going to influence. So if you look at as the temperature is increasing, the total amount of the growth could be reduced, and especially we learn from the insect growth, the degree days concept is going to be an important one. The changes in the rate of crop development as a function of the temperature could be seen in terms of the how these indicate the optimal temperature range differs depends on the species and the crop type. I don't have much access to the Indian data, but that's one reason I have used the US data. You could see in terms of the maize and soya beans under different scenarios of the best possible climate scenarios. And it has been seen that while the best climate deviation has shown that there is going to be high amount of production and low production. So the and the circles indicate the mean value of each distribution, whereas blue circles indicate mean value of the baseline for the yield distribution. And you could see that the baseline value is here, and the deviation shows that you have the climate influencing each and every crop under each of the probable model, and thus people are looking in terms of the wheat, maize, rice, soybean, which are the major crops across the world, how they will be responding to the probable climate change scenarios, and how one should be looking in terms of what is going to be the probability. So the impact of marginal soil capability improvements on the distribution of predicted average annual crop yields for the maize and soybeans from 1950 to 1958 in US has been shown in terms of how it is going to be best and worst possible climate scenarios. So you will be seeing the gray-black histograms represent the predicted distribution of country-level averages in the soil capability classes without the marginal soil reclamation. The green orange circles represent the distribution of the means without marginal soil reclamation, and the blue circle represent the mean values of the baseline distribution to no climate change between 2000 to 2008, and 2050 to 58, no slowdown in yield growth trend. So this shows that with the possibility that there is going to be a climate change, and if you don't adapt to these climate change using the required practice changes, what is going to be the impact of the climate change on the agriculture production. In terms of the crop revenue and in terms of the temperature change, so from the T0 to T1, you could see the wheat without switching, with switching, you will show that the maize is going to be more beneficial to the farmers in terms of the temperature increases in those zones. But in terms of the fruit orchards are going to be important for the long-term sustainability, because the polycultures are going to be considered as having higher ability to sustain the climate change regimes. I think let us conclude this part. So the most critical part in the climate change adaptation is discourse of the methane emissions from the agriculture systems from the Southeast Asia. We have one technical study from the India which shows that the what is going to be the methane emission potential or the coefficients from the Indian agriculture when the rice is grown. So you could look at different water regimes under the irrigated, rainfed, and deep water and upland systems, and what is the methane emissions in terms of the coefficient and the total. So you could see that the total rice area is about 44.7 million hectare, which is going to be approximately emitting 3,483 gigagrams of the methane to the during the approximately to the from the ecosystems in the India. And this is what considered to be important in terms of contributing to the global warming. I have one case study where we have participated in terms of how the farmer will be adapting to the changing climate. So the cropping patterns determined by the climatic conditions in the mid-altitudes of villages of the Himalaya. So the farmer will be starting doing agriculture, first showers in the April, May, sowing of 2 cultivars of the barnyard millet, Mathua and Bagan, and 2 cultivars of the finger millet, Jaria and chauras in the monsoon as monocrops. So he will be looking at it. So in the mountains, all the agricultural land is not planted together. The farmer will be starting with a small plot first. So when he looks at the monsoon is normal and start by the mid-June plowing of the remaining fields. So if there is a delayed monsoon, plowing of all fields and sowing all cultivars of millets. So when there is a delay of monsoon, the entire area is plowed and then it is planted with only millets, which is considered to be able to produce some grain under the water stress. When the monsoon is proper, sowing of introduced cultivar of the maize is done in some part. When the sowing of cultivars of the maize is done, normal growth of both cultivars of the maize, then soybean and mungaricard cultivar of the finger millet is sown through the seed is done. But when there is a poor growth of cultivars of the maize, then 20 days after the sowing, then fields are plowed afresh and mungaricard cultivar of the finger millet is sown. So this mungaricard cultivar is considered to be extremely tolerant to the water stress and able to provide grains. And thus this finger millet, which is a staple food in the Himalayan region, some regions of Karnataka also produce this as the ragi. So this is a adaptation that we have seen the farmers are doing at the plot level. So individual field level adaptation has been documented by us to show that how the farmers will be looking in terms of changing weather events by following the climate calendars and by looking at the what is coming that year, accordingly the planting is done. This is the adaptation. And the other thing is a long-term adaptation that has been seen by us in the Khasi and Jaintia hills is using bamboo drip irrigation system. The soil is very thin under the parent rock here. So the people has constructed extensive bamboo-based drip irrigation systems where the water will be slowly released by drop. And this is about 200 years old in some of the villages. And such examples of water harvesting is available across several of the water deficient ecosystem zones. You could be seeing this as the poly-lined water harvesting tanks, which is common across the Himalayan region and also in the tanks in this South India. In Ladakh, you will be seeing these ice stupas, which are constructed, and when the summer growing season, the melting ice is providing the irrigation water to the agriculture crops that are required. So water management is going to become important facet of adaptation for the human society here. So the impact of disaster risk reduction is going to be critical on the development. So the GDP will increase only without the disaster. But what is happening with each of the disaster event, the amount of the development is going to reduce. So when the frequency and intensity of these disasters is going to be increasing, the gross domestic product is going to decrease and the ability of the society to sustain with the economic investments is going to becoming less and requires more investment to recover back into a sustainable society. And thus resilience is going to be important. The three important elements of the resilience are transformative capabilities, absorptive capabilities, and adaptive capabilities, which are going to be required. A society has to have the ability to transform. It has to have absorptive ability to absorb the losses and adapt. So adaptation is what we are looking in terms of climate change, but also required to have the transformative and absorptive capacities for such societies to be sustainable. And thus, in terms of the ecosystem, resilience is going to give us a lesson in terms of adapting to the climate change by increasing the persistence, increasing incremental adjustment, and increasing the transformation capacity, and thus provide the ability to reach the sustainable development goals. So resilience is about bouncing back. You will see the development pathway of country A where it will be reaching back very quickly, but with resilience is also about converting risks into opportunities for systemic transformation. And thus you have to look in terms of what is that the measure of sustainable development that we are using in terms of looking at the how we are going to achieve the required adaptation to the climate change. So this is what I have for you